Pseudocode. Pseudocode is an informal, high-level description of the operating principle or other algorithm. Basically, pseudocode is implemented into regular, compiled machine-understood code to allow for human understanding. Pseudocode can be used in all computer languages, for example, Pascal, Basic, C, C++, Java, etc. It allows code written in these languages to be more user-friendly and understandable to programmers who aren't familiar with the syntaxes used in that language criteria. Pseudocode isn't conventional and is only used for understanding code. There's different types and styles of pseudocode. Pseudocode doesn't have its own systematic standard form. Programmers would generally use their own style and syntax or borrow control structures. There are two types of pseudocode. One is natural language. Natural language is basically using sentences to describe the program in plain English. There's also mathematical style pseudocode. Consists of mathematical notation. This is a compact and often informal notation that can be understood by a wide range of mathematically trained people. As you can see on the screen, return sigma means is a loop. There are 3 steps to writing your pseudocode. Firstly, you will write out your code in plain English. This is pseudocode on the screen. 2. Then, after reading over your pseudocode, ensuring you understand what routine you should do, you should turn the pseudocode into comments that will describe what you are writing. This form of coding seems to make reviewing of the code far more efficient and easy. You can review your pseudocode without even looking at the source code. This code also supports the idea of iterated refinement, which was proposed by James H. Wilkinson. To break it down in plain English, first you would start with very complicated code, almost tedious. With pseudocode though, you have 3 levels of refinement to help find errors. This is underlying basis to iterated refinement success levels of refining. There is high level design, which is your design, the middle level design, which is your pseudocode, and finally your low level design, which is your source code. So if your code does not compile, what do you do? First, you review the high level design. Ensure your code is doing what it's supposed to do. If everything is correct there, you move to the middle level design, your pseudo. Double check process makes sense. Once again, if everything is correct in that level, you move to low level design. This is where you would scan over your source code. Check that you translate correctly and ensure there is no mistakes. Pseudocode makes changes easier. This form of coding essentially lives by the method of catching errors at the least value stage. Pseudocode minimizes commenting. Since the commenting is done before the code is written in pseudo, there is no need to comment any further afterwards. Pseudocode is easier to maintain with other approaches. Design is kept away from code, and when one changes, the two will disagree. With PPP though, the pseudo statements become comments in the code. As long as the comments are maintained, the pseudo documentation will stay correct.
Why use pseudocode? The programming process can be complicated at times. You must first understand the program specifications, then you can organize your thoughts and create the program. This is a difficult task if the program is complex. You must break the main tasks and must be accomplished into smaller ones in order to be able to eventually write fully developed code. Writing pseudocode will save you time later during the construction and testing phase of programs development. Some advantages of pseudocode. It is easy to use and create with text editor because it uses English-like statements. No special symbols are used to represent specific functions. Very little specific syntax is required. Statements can generally be translated on a one-to-one basis to any high-level language. Pseudocoding the problem logic first drastically reduces time spent in coding, testing, and debugging systems. Some disadvantages of pseudocoding may start with its lack of standards. One's logic instructions may not seem as logical as the next. Given the unstructured nature of pseudocode, it has few rules and is hard to standardize. One programmer's logic might not see the logic written by someone else. Another disadvantage over other modeling tools like flowcharts may be pseudocoding inability to show logic flows or the bigger picture, whereas flowcharts provide an overview of logic and can be understood at a high level. Pseudocode is far more detail oriented and requires more concentration and practice to see the bigger picture.
That's it.
I was expecting you to pause that.
Alright.